So first of all, probably a thing that you noticed is that even though our hero is out of the way of the collider, he's not falling down, so the gravity is not implemented. So I'm going to assign a private variable called gravity. I won't be needing to changing. It'll be the regular 9.81 unity units. Float gravity equals 9.81, and now we're going to use another character controller function is grounded. So we're going to set up a conditional statement. If character control that is grounded, and now we're going to implement all of these functions. If our hero is moving through mid-air, we don't want him to rotate or move around while he's in mid-air. So we're going to be putting all of this within the is grounded conditional, and now we're going to be applying one command outside of this conditional, and that is going to be gravity. So we're going to be accessing this vector3 dot y, so the y-axis, minus equals, so this will be the same as writing move dir dot y minus equals. We'll say equals plus minus whatever I want to subtract from this vector 3. And it's going to be gravity, and times that delta time to make it frame rate independent. Now that I think of it, we actually do need to extract one of these commands out of this conditional statement, because currently we're just changing the vector 3 up here, but nothing is being applied to the character controller itself. So I'm going to cut and paste and apply it at the end of this update function. Save it, and I'm gonna bring it back to Unity. Okay. Everything seems to be solid. Well, let's play. Okay, the character is falling down. We're getting some gravity. It's turning around, probably a little bit too fast, but it doesn't matter. And we are getting the proper turning and the proper movement. Let's see if we also get proper gravity. Okay, pretty good. We actually could turn down the gravity a little bit, even though it'll be maybe physically unrealistic. Visually, it will look better, and that's all that matters, considering most of these values are really fake anyway. I'm going to give this a value of just 5. So, Doctor, if you recall the goal of your mission, it will be to have some animations and then have the animations to switch to physically realistic movement simulation from any point and angle. So that means we're going to be switching from mechanism animations onto something called a ragdoll effect. Let's at first implement the mechanism. I'm going to go back into Unity, and I only have 2 animations, so this will be relatively fast to set up. And I'd like to drop off the animator into just this models directory. So I'm going to click on the folder, go into the create menu. This is going to be a little bit, actually no, it's going to be up here in the view of the screen capture, animator controller. And I'm going to name this Spaceman anim controller. Just double click on it to bring up the animator. Now we're going to bring up the Spaceman here. Open it up, and first of all, I'm going to drop in the idle animation. This is going to be the default animation. I'm going to create the walk clip, create a parameter on which it is going to be transitioning from the idle to the walk script, and I'm going to just name this translation. Now we're going to set up a condition on which the animator is going to transfer from one animation to another. So I'm going to right click on this state, make transition, drag it over to walk, click on the arrow. Now it's going to ask us I'm going to minimize this preview so I have a little bit more room. Upon which condition do you want the transition to happen? It currently says exit time, so by the end of this animation, I want it to be by this float. So it's going to say, if it's going to be greater than 0, then start transitioning to that other animation. We want to do the vice versa of that condition. That's going to go back into the idle animation. Make transition from the walk statement, bring it back to idle, bring it back to this float up here, and this time it's going to be less than 1 here. So when it's less than 1, it's going to be transitioning back into the idle animation. So let's click on our hero, apply the animator component. We just called animator. Okay, it's going to ask us for the avatar, which we want to use for this animation, and also the character controller. So just go ahead and drag in Spaceman avatar, and for the character controller, drag in this Spaceman animation controller. Yep. If we hit play now, we will see the idle animation take place, and here we have our hero waving, but when we move around, there's no animations on the movement. So let's go back into our script and attach a couple lines of code in order to transition from the idle state to the walk state when the character is moving around. So within this class, we need to reference our animator. So we're going to call it animator. Then go into our start function and assign it to the component. Get component, animator. Okay, now within our statement up here, within the conditional, I'm going to add another line of code, and I'm simply going to assign this value up here, the up-down control, the vertical, that's going to go from -1 to 1. And for me, it doesn't matter which direction the character turns. All I care about is that the character is turning. That means I'm going to use an absolute function, and this is relatively simple. So we're going to address the animator that set float, and in our case, it's going to be translation. Now we're going to take the absolute statement, so math f class dot absolute dot abs, and we want to address this float up here, up, down control, and make sure all of our parentheses are closed. And that's all we need to do in order to transition the animation from the idle to the walk cycle. Okay, perfect. Let's see if this works out. Okay, the hero is turning, and the hero is walking. He's transitioning from the idle state to the walk state. And then he's gone. Pretty cool. Now, let's just adjust these colliders up here and add a couple more for the other walls. So I'm going to make sure this matches the angle. Switch this back to local. Make sure that it's aligned all the way across our corridor, the airlock. Let's switch this to orthographic by clicking this option. Okay, like so. Now we want to add a second one. It's going to be the opposite angle of this collider. Actually, before I do, I'm just going to give it a name. I'm going to name this bounds ground. In this, I'm going to name bounds and downs, bounds side. And that's okay if they have the same name. So Command D. Okay, so currently it's at -59. And where we want to, in order to get the opposite direction, we simply add 59. Okay, let's just move it up. Now, because none of these actually have rigid bodies attached, it doesn't matter if they intersect. And I'm going to be removing the mesh renderers and the mesh filters from all of these boxes, but because I want to assign them and make them visible, I'll keep them visible for now. So this one's going to go up here, and the top one is going to go on the bottom. So let's just copy, paste this, and move it a little bit to the left. Come on. Okay. And now the top one to move to the bottom. And there she goes. Move it a little bit higher. And then to this side here. Okay, don't worry about this gas tank. We'll concern ourselves with that in a moment. Okay, now I've got these. I'm going to expand the ground here. No, I want to keep this orthographic. Sometimes I get a little confused by these things. Okay. And move this so it fits the ground. And we also need to position this so it fits the entire corridor. Okay. I'm going to add a couple more colliders actually. And those colliders I'm going to add onto the gates. So let's first of all take care of these colliders, make sure that they are in their proper positioning. And that's good enough. I'm going to paste this once again, make sure that this gets a proper name. Okay, that looks pretty good. Let's move this actually a little bit higher. Okay. Looks pretty good. I'm going to take all of these. I'm going to create an empty game object. Just going to call it bounds group. Take all of these objects. I'm going to unselect the group and drag them all as children of the bounds group by just dragging them on this parent. There we are. Now I'm going to open this up, and currently I've got all of these selected, so I can do a bulk component removal. I'm going to right click on mesh renderer, don't need it. Right click on the mesh filter, don't need it. All I need are these colliders. Okay, I'm going to add a couple more, like I said, to the gates. Individually, spaceship corridor gates, I'll need to add one to the left, just by going component, physics, and box collider is cool. Gate to the right, component, physics, and box collider. Now we've got a few more options in our character controller, which we can use to make the character walk up the stairs or walk up on inclines. So let's take a look at those. Now I'm going to just press play, and then we're going to modify these components. I want to leave them at the default, but I kind of want to demonstrate what they do. Okay, I'm going to zoom in on the guy, and I'm going to go into perspective mode and select him. Actually, I do want to select him because I want to modify these components. And say currently he is moving around. We see that there he is, he's going, and we are not falling down through anything. Our mechanism is also working. Okay, but say we want him to walk up these walls. He's not going to walk far because the upper collider is going to stop him. But say if we change the slope limit to something pretty high, let's change this to 80 degrees, then our character actually starts walking on these slopes. In case you are using some sort of ramp, this function will be useful, and it just adjusts it to the highest angle, and the character will move from that angle or lower. Step offset is something that's being used for stairs upon you're deciding how much will the step rise to make the character walk on it. Skin width is how much two colliders can penetrate each other, and this will determine how close they can get to one another. And if you set this to something large, it may reduce jitter if you're getting jitter, and if you set this to too low, you might get situations where the character can get stuck. Min move distance is something that's also used to reduce jitter, and it's saying that if the character moves around, and if he moves around too much across one single point, don't move him around unless he gets up across any certain distance. You want to keep this at 0 unless you're getting some jitter. And this concerns ourselves with actually just the collider, center of the collider, radius, and height. So currently we have determined the best script to use for the character movement. We have also scripted things in Mechanim, and we have proper movement scripts in order to make the character move around and fall down the screen.